This is my mechanical arm refueler that I made in Minecraft. It is able to locate any ship within its sphere and to automatically go towards the ship's dock in order to refuel it. It achieves this using the computer craft mod and its GPS function, and it does not require any sort of chunk loading in order to function correctly. In this video, I will show you how to make this arm for yourself in survival mode so you can use it with your own aeronautics ship in order to make refueling them easier. Before starting, you should know the video will be split into 3 main parts: setting up the GPS system, setting up the arm contraption, and setting up the computer system on your own ships. There is also an extra section near the end covering certain things that don't need to be in the setup guide. It should be noted that this is version 1.0 of the current ARM build, and despite my attempts at fixing most of the bugs I encountered on this project, you still may encounter some yourself. In that case, let me know on either the GitHub page or in the comments section down below. Also, before we start, make sure to hit that subscribe button. So let's get started with the GPS system. This is very simple, and in all honesty, I'm just basically following the guide for setting up the GPS system on the CC Tweaked website. If you don't want to listen to my voice, I've linked the instructions down in the description. Anyways, you will find that I've made a very simple schematic for the GPS system that I used. It's basically the exact same one from the wiki, but I figured it would make things simpler if you don't want to measure it yourself. You simply want to place this GPS near the arm such that the chunk it is in is always rendered while you're near the arm, and in my case I just like to put it under the arm, which is why I have this hole dug up. Setting it up is very simple. All you need to do is open your F3 screen, right click the computer, and type this command. Once inside the file, all you need to do is to type this command, and then to type the next 3 numbers based off the coordinates of said block. You can find its coordinates in the F3 screen as mentioned, located in the bottom left. Once done, simply press Ctrl and then click Save, and then press Ctrl again and then click the Quit button using the arrow keys. Afterwards, you want to type in Reboot. This should work straight away. Now you do the same thing for the rest of the computers. And that's basically it for the GPS system. This is essential for the entire contraption to work, as it is used to both find the arm and the ship computer's coordinates, and to calculate based off the yaw, pitch, and roll of the ship, the global coordinates of the ship's dock itself. Now let's start making the arm. You will find that there are 3 types of schematics that I've linked, each one having the name Gibbon. For the Gibbon 28 and the Gibbon 68, the only major differences between the two are the arm length. The Gibbon 28 has, well, a 28 block reach, while the Gibbon 68 has a, well, 68 block reach. Then there is the Gibbon Bear. This is essentially the Gibbon 68, except that it only contains the necessary blocks to make the arm itself. Not only that, but it being only bare bones means that it's the schematic that you should use if you are planning on changing the arm length, as in order to make the arm shorter, you simply need to reduce the distance between the limbs and remove some of the pipe pumps. And if you want to make the arm longer, you simply need to add more pipe pumps and to add the occasional chain conveyor along the way. You might have noticed that in the bare bones version I used andesite blocks as the building block for this arm. This is intentional. Andesite blocks are classified as super heavy blocks, and you need to make sure that the arm is pretty heavy itself in order for it to not jerk around while moving. This becomes really important if you want to extend the arm length, as you will need to add more supplementary blocks if you want the arm to not jitter like crazy. Onto the actual assembly part, I will use the Gibbon 68 schematic as an example. On all schematics, you'll find that each subsequent rotating piece is not connected to each other. This is intentional as it allows assembling it to be as easy as possible. Note that currently the arm only works in the vertical upwards direction, and rotating it to be horizontal or upside down will cause the arm to malfunction. This is something that I haven't implemented yet, and that I will in future updates. When placing the schematic, make sure to not rotate it in any way. It literally just won't work at all if you rotate it due to some inconsistencies with how certain create blocks function in different orientations. Keep in mind you can always change where the arm is facing once you've fully set it up. Once you've placed the schematic, before assembling each of the parts, I recommend adding some sort of scaffolding underneath each of the floating pieces, as it will make assembling them much easier. Moving on, let's assemble the first piece. First off, make sure to right-click the ring bearing so that the arm base itself is assembled, and to then right-click the first limb bearing afterwards. Once done, you can then assemble the first limb by using a contraption assembler and then using something like rope, or in this case a plunger launcher, to bring the piece closer to the first limb bearing. Once close, you can use a slime ball to stick both pieces together. After this, you simply want to repeat the same thing but for the other pieces, always making sure that the subsequent bearings are all assembled themselves before you stick each piece together. Okay, so when I was making this, I thought using the plunger launcher was a good idea. It is not a good idea. This entire ordeal took like 15 minutes, which I guess compared to gluing everything while everything was connected, it it probably was still a bit more time efficient. But in all honesty, if you're doing this, uh, use rope pulleys, put them atop the limbs, and then put some rope hinges on the limbs themselves in order to use the rope. Or you can install this Create Aeronautics toolgun mod, which should hopefully make this entire thing much easier than how I did it in this video. Once you fully assemble the arm, you just need to use the wrench to connect each of the VS pipe hoses. Also make sure that the chain conveyors are connected. Once you're done, you can then put your source of SU over here, and we can then set up each of the 5 computers. This is very straightforward to set up. There are 4 bearing computers, 1 gyro computer, and 1 controller computer. To install each program, simply right-click each computer, and to copy-paste the Pastebin command that I've linked down below and in the GitHub page. From there, follow the instructions to install each program based off which computer it is. If you mess it up, you can simply just copy-paste the command again in order to restart the script. Once you click exit, the script will automatically reboot and the program will start. It is important to set up your source of SU and the other 4 computers before setting up the ARM controller itself, as it will automatically calibrate itself once the controller is set up. In this part, I pressed the wrong button, so you can press Ctrl T to stop the program, and you can then use the Pastebin script again. We can then set up the ARM controller computer. In this installer, however, you need to put in some values. It will first ask you what direction you want your arm to be in. This is the same as the global coordinate system. The negative z-axis points north, the positive x-axis points east, the negative x-axis points west, and the positive z-axis points south. In my case, I want the arm to point south, so I will pick the south option. Then it asks for the arm length. You want to put the length of your arm, which in my case is 68. If you've used the given bare schematic to make a custom length arm, simply enter your measurement here. Once you've finished setting the controller up, you will find that the program starts right away and should hopefully calibrate itself to its idle position to the orientation you asked it to be. Once it's in its idle position, Then the arm is fully set up. Now we can move on to the ship section. In order for the arm to detect the ship itself needs its own computer, as each different one can have their own dock positioned somewhere else on the ship. First of all, you need to figure out where to place the ship controller. This controller is pretty compact as it's only formed of 6 blocks. The button located on the left side of the computer can also be replaced with a redstone relay if you wish. I also recommend placing the schematic pointing towards the ship front in order to avoid any confusion. If your ship in particular does not have a defined front, then it's up to you to choose what the front of your ship is going to be, as it's crucial to determine the orientation of your dock. Once set up, we can then use the same Pastebin installer to install the ship program. Once you are inside the terminal, however, there are some things again that you need to input. First off, it wants you to find the offset coordinates for your dock. When I mean offset coordinates, I mean with respect to the computer as the origin point, aka considering the computer as 0, 0, 0. Starting off, we use the same coordinate system that Minecraft uses, but with the north pointing to our ship's front instead. For example, my ship's front is this way, which makes it north, and thus the negative z axis points this way, making negative x point left, and positive x point right, and positive z pointing back. We can then find where the paired docking connector is using this orientation with the camera treated as the origin point. For example, the dock is left of the computer, so we count 0, 1, 2, 3, 4, 5, which makes that negative 5. And the dock is south of the computer, so we count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That makes that positive 10. And then we have negative 1 just below because it's 1 block below the computer. Thus, we have coordinates negative 5x, negative 1y, and 10z. Secondly, we need to find what direction our dock is facing. This is self-explanatory. You know your ship's front, so if the dock connector is facing to the front, then you press the number for front, and so on. In my case, the dock is facing left. Finally, we need to determine what orientation your ship was assembled in prior. This is necessary because the navigation table can give different yaw angles depending on what orientation your ship was assembled in. If you remember this beforehand, then you can skip finding the angle and just click which direction is correct. If not, then you need to find it yourself. The installer helps you with some basic instructions, and basically what you need to do is to align the arrow from the navigation table on the computer to your ship's front by rotating your own ship. Once you're close, you can then press 1 and it'll give you the angle the table is at. So for my ship, I'm basically just going to align this arrow to the front of my ship. Now my ship should be roughly aligned with the arrow. You can then press the corresponding direction at which your ship was assembled based off this angle, which the installer shows. For my case, the table angle is around 271 degrees, which is closest to the north, which means I assembled my ship pointing north. If your angle is inconclusive, you can always press restart and it'll give you the angle again once you realign the arrow with the front of your ship. Once it's done, you can then press exit and it'll do its own thing. And that's basically it for the ship section. Here I'm going to show how docking the vehicle works. Once you press a button, it'll play a sound on whether it can safely dock your ship, and it'll go towards the ship's dock in return. It will stay at this position so long as it detects that the ship's dock is still there. As a result, if you turn off your ship's dock, then it will eventually go back to its idle position. If your ship's dock is not in a safe position, however, like I said previously, it will play a fail sound. And this tells you to place your ship in a safer position where the arm can intercept it without potentially hitting the ship. So I'm just going to rotate my ship around. So now I'm within the arm's radius, but I'm still in an unsafe position. So pressing the button will play a fail sound. And thus I need to get into a better position. It plays a success sound, which means the arm can be docked. But as you can see, there's another problem here. When I pressed the button, the ship was still moving, and as a result, the arm is a few steps behind. So here I just want to reset the arm, so I will just turn off my dock and turn it on again. This is something you need to take note of once you want to dock your ship to make sure that the ship is not moving at all. And as you can see, it is perfectly in place. And my tank is getting refueled. And that is basically how you use the arm. Now here's some extra things you can take note of that I don't think fit exactly in one of the 3 sections. By default, the arm won't render outside your render distance. The only way to fix this is to actively load the chunks your arm is in. Something else important to note is that if you were to make a bigger arm using the bare schematic on a server, you need to make sure that it still fits within the server's minimum distance. A server with max 8 render distance, for example, can only fit a 128 length arm before it starts being outside the server's render distance. Next up, if you ever need to change the values in one of the computers, you can do so by simply holding Ctrl T and then typing configure. You can then modify any of the values you want. Next up, this isn't in the configure settings currently, but you can access the ARM channels by holding Ctrl T and typing edit protocols/channels. You can then modify the channel values that the ARM uses. This may be useful if you want to prevent certain ships from accessing your ARM in a server. Finally, in order to get the arm length for custom length arms, you simply take the length of one single limb, make sure both limbs have the same length, and then multiply it by 2, and you get your resulting arm length. And that's pretty much it. Let me know if you guys face any problems related to the arm down in the description. And make sure to subscribe. See ya.